Hello. Welcome to the first segment of our video lecture for this week on OLAP. Please remember that this is copyrighted. Before we begin our discussion of OLAP, I want to be sure we understand part of what drives the need to be able to process data to create OLAP reports. Big data is a term that refers to the enormous and continually and quickly growing amount of data. Just think about all the information we can get using a search engine, or even all the information that is stored in social media networks. Let's try to get some perspective on how much data is stored. Here's a list of storage capacity terms. Remember that a byte stores one character. Desktop computers today normally list their storage in gigabytes or perhaps even terabytes. When we get to petabytes, exabytes, zettabytes, and yottabytes, we get into very large numbers that are sometimes hard for people to understand. These approximate reference values I've typed out on another screen here so that you might get a little better idea. A gigabyte is 1 billion bytes. That's written out like that. A petabyte is 1 quadrillion bytes. We've passed trillions now. 1 quadrillion. And a yottabyte, a 1 with 24 zeros behind it, is 1 septillion bytes. So hopefully that gives you just a little bit of perspective now on the sizes of information we're talking about. There are many business intelligence systems, and the ones we're going to focus on right now is online analytical processing, otherwise known as OLAP. With OLAP, we use arithmetic functions such as sum and average. But the reason OLAP is noteworthy is because it's dynamic. The viewer can change the view of the report. The report we get from OLAP systems is called an OLAP cube. Please be sure to note that this is not a cube by the strict mathematical definition of 3 equal sides. It's called a cube because it is multidimensional. It can have many more than 3 dimensions. OLAP cubes are composed of dimensions, which are attributes of measure. Measures are facts, typically numeric data items that are summed, averaged, and so on. Excel pivot tables can be used to create OLAP reports. This example from your book illustrates one of these Excel pivot tables. The pivot table was created using the Insert tab and the pivot table function. We have the pivot table list here. Notice this pivot table has many more than 3 dimensions. In this pane on the side, we are able to select the elements that we want to display. And using this pane, we can display different elements in different formats as we view the report. In just a moment, I'm going to walk through an example of creating a pivot table, and that will give you a better idea of how these work. Here's another one of the pivot tables that we don't have the selection pane over here. We are able to simply open them out with the boxes on the left side. We can open and close and drill down into our data to get the information that we want. Now, in our next segment, I'm going to create an Excel pivot table and walk you through some of the capabilities. Thank you for your attention in this segment. Hello. Welcome to our second segment of our video lecture for this week. In this segment, I am going to hopefully explain a little better about pivot tables in Microsoft Excel. I have an Excel spreadsheet here, and if you recall in your book, you can write SQL to create an Excel spreadsheet from your database tables. Also, in Microsoft Access, you have the ability to quickly export a table or a portion of a table to a Microsoft Excel spreadsheet. Once you have your data in a spreadsheet, we can create a pivot table, which is a type of dynamic OLAP report. To do this, once we have the spreadsheet, and I just created one here of arena ticket sales for 3 days, we go to the top and click the Insert tab. All right, when we click the Insert tab, we want to choose Pivot Table. Now we want to select the range, and I want my entire, you don't have to have the entire range, but I want it. I want the entire table, the entire spreadsheet, okay? And I want it to go into a new worksheet. And here is the place where I'm going to make my pivot table. Notice right here, these are my dimensions: event, day, gender, sales. Those corresponded to my columns. Okay, I'm going to choose these dimensions to go into report filter, column labels, row labels, or values. Okay, I'm sorry this is kind of cut off, the limitations of this recording software. What we can do, first of all, we know values has to be our numeric value, our measure. Remember we spoke of measures. Sales is a measure. We're going to drag sales into the value box. Okay. Now let's say I want my column to be events, so I'm going to drag it to column, and I want my rows to be days, so that I have Monday, Tuesday, Wednesday on the side. Now over here I've just created a pivot table where I have each day, I have the event, and how much I sold. Well, that doesn't look like currency, and I want to do that. Okay, so down here where it says values, I can right click on the sum, perhaps, there we go, and I choose value field settings. At this point I can change, instead of sum I can do count, average, min, max, product, mini, multiply, count numbers, all manner of things. I still just want the sum. I want my totals. I can also change my number format to currency. And so there we go, and that's what I want. So that looks a little better. Now, let's say, okay, I want to look at this a different way. I want to look at it so that my columns are my days. Well, I'm going to deselect my event from my columns, and I'm going to move my day over the column. I'm going to put my event as my rows. Right, now I have a totally different view. I have my events here and my rows here. All right, now let's say I had gender stored, how many males and females bought tickets. I'm going to use that as a report filter. I'm going to drag it down into report filter, and this pops up on my pivot table. Now I can select, let's say I want to see how many females bought tickets each day, so I select female. Now I see that on Monday no females bought any arena football tickets. On Monday there were $300 of rodeo tickets and $100 of tractor pull tickets. On Tuesday no females bought any tractor pull tickets, but enough of $50 worth and $175 worth respectively for arena football tractor pull. I can also change that to see males and give those totals. As you can see, as we're looking at this report, we are changing the way we can see it. We are changing our views to fit the information that we want. That's what a pivot table does, and that is the beauty of online analytic processing. It is dynamic. We can change our report as we're looking at it. Hopefully this example has given you a better idea of what that means. Thank you for your attention. Hello. Welcome to the third and final segment of this week's video lecture. In this segment, we will discuss distributed databases. Please remember that this is copyrighted. An early solution to the large amount of data being stored was simply spreading that data out among several servers. These groups of servers were called server clusters. When we have a database that's stored in a server cluster and stored on 2 or more computers, we refer to that as a distributed database. Distributed databases can either be partitioned, replicated, or both. When a distributed database is partitioned, that means it has been broken into pieces, with those pieces stored on multiple computers. When it has been replicated, it has had copies made and stored on multiple computers. Let's take a little closer look at some examples of the types of distributed databases. First, we have an example of a non-distributed database, a single processing computer. Next, we have the example of a database that has been partitioned but not replicated. As you can see, we have pieces on computer 1 and pieces on computer 2, but only one copy of each. Next, we have a non-partitioned database that has been replicated. We have all the pieces on computer 1 and then a replica of those pieces on computer 2. Finally, we have an example of a database that is both partitioned and replicated. We have some of the pieces on computer 1. We have some of the pieces on computer 2. And notice that piece Y has a replica on computer 2. So why would we want to distribute our database anyway? One of the big reasons is performance. If the workload is shared among multiple computers, our performance improves over the performance of a single computer can deliver. Also, with multiple data centers located across the country or even across the world, we can reduce communication delays by placing the computers nearer to the users. Another reason to distribute is control. We can have much more control over authorized users and permissions by putting certain ones on one computer and others on a totally different computer. Distributing definitely has its advantages, and for read-only replicas, it does not pose too much of a problem. However, with other installations, we soon run into some issues that are somewhat complex. One set of problems arises when we have multiple users updating replicated databases. The issues we could encounter here are inconsistent changes, one user deleting a record while it's being updated by another user, and violations of uniqueness constraints. Another installation that poses problems is a partitioned database that's not replicated. When users attempt to update data that spans across distributed partitions, the transaction has to start on both computers, and the same transaction can't commit on one if it's not allowed to commit on the other. To solve those two types of problems, a more complex locking solution is needed. Distributed two-phase locking would need to be implemented. It's complex and expensive, and it's out of the scope of this course. These are just a few of the examples of the complex problems we encounter in distributed databases. As a result of these complexities, distributed databases are really only a solution for very large organizations with a real need for their advantages, and with the great expertise and large amount of funding that's needed to support them. Thank you for your attention.